Hello, today we are going to start a series of our technical events. We will talk about performance today and our speaker Vadim Kovalkov. Uh, in general, we are going to create three events, and this one is first one. Let's go, Vadim.
Okay, hello everyone, and I would like to present your performance battle. In this battle number one, we will compare the solutions of Spring Web and Spring Web as native. And this is the first one performance battle. The other will be related to the Quarkus, Micronectar, Helidon, and etc. So let's move on and take a look on the agenda. And first of all, I'll present myself and who am I. I'll provide you a brief introduction in the technologies and solutions we'll use during this performance analysis and the business idea I've created for these purposes, and dataset preparation, compare Spring Web and Spring Web as native performance and some kind of metrics, and I'll provide you sum up for all this performance battle. Okay, let's move on. And who am I? I'll tell you a bit about my experience, domains, technical stack, and social networks. So my name is Vadim Kovalkov. I'm a chief software engineer at EPAM Systems with more than 7 years of IT experience, and my key business domains are finances, human resources, crowdfunding, and healthcare. I'm a deep-shaped person with core knowledge in the GraalVM stack area, and I have proven practical experience with development with Java, Kotlin, Spring Boot, Spring Native, Jeep, Docker, OpenAPI, Gradle, Postgres, and database migration tools such as Flyway and Liquidbase. I'm familiar with React.js, Kubernetes, and the kind of development operations like GitHub and GitLab CI, performance testing with JMeter and Gatlin, and Google Cloud Development and Architecture. I have a GitHub profile. You could visit it. I'll provide you a QR for this research. You could find the previous one researches, and you can find me in LinkedIn and GitHub and Instagram as well. So what I'll introduce, let's take a look on the Spring Boot, Spring Native, AOT, GraalVM, overview build steps, overview outputs. So what is a Spring Boot? Spring Boot is simple and makes it easy to create standalone production-grade Spring-based applications that you can just run. The features of Spring Boot: create standalone Spring application embedded Tomcat, Jetty, or Undertow directly. No need to deploy raw files. Make jar, not var. I believe in it. Provide opinionated status and dependencies to simplify your build configuration. Automatically configure Spring and third-party libraries. Providing production-ready features such as metrics, health checks, aliveness and readiness probes, for instance, and externalized configuration. And absolutely no code generation and no requirement for XML configuration. Yeah. Hello, Josh. Okay, what is a Spring Native? Spring Native provides support for compiling Spring application to native executables using the GraalVM native image compiler. So compared to the GVM, native images can enable cheaper and more sustainable hosting for many types of workloads, such as microservices, function workloads, well suited to containers and Kubernetes. Using native images provide key advantages such as instant startup, instant peak performance, and reduced memory consumption. We will take a look on this metric a bit later. So there are also some drawbacks and trade-offs that the GraalVM native project expect to improve on over time. Building a native image is a heavy process that is slower than a regular application. I will compare these metrics as well. And a native image has fewer runtime optimizations after ramp-up. Finally, it's less mature than the JVM with some different behaviors. And the key differences: static analysis of your application from the main entry point is performed at the build time. The unused paths are removed at build time. Configuration is required for reflection resources and dynamic proxies. We'll briefly take a look on it. Class path is fixed at build time and no lazy loading. Everything shipped in executable will be loaded in memory on startup. So some code will run at the build time. Okay, the limitations I will provide you a bit later. There are different kind of limitations I faced with, and I'll bring to you. Okay, what is ahead of time? Ahead of time is the act of compiling high-level programming language into a lower-level language before execution of a program, usually at a build time, as I've mentioned before, to reduce the amount of work needed to perform at runtime. Spring AOT inspects an application at a build time and generates an optimized version of it. Based on your Spring Boot application annotated main class, the AOT engine generates a persistent viewer of the beans that are going to be contributed at runtime in a way that bean instantiation is as straightforward as possible. Additional post-processing of the factory is possible using callbacks. For instance, there are used to generate the necessary reflection configuration that GraalVM needs to initialize the context in a native image. The engine goes through the following phases. Prepares the underlying bean factory, so the relevant bean definitions are available. This typically includes bean definition model passing, such as configuration and data classes, as well as any additional post-processing of the bean factory. And code generation based on the prepared bean factory and additional processing of the bean factory used to optimize the runtime. And what is GraalVM? Graal is a Java VM, JVM, and JDK based on Hotspot Open JDK implemented in Java. It supports additional programming languages and execution modes like ahead of time compilation of Java applications for fast startup and low memory footprint. Okay, and major differences of the GraalVM in comparing with the JDK are GraalVM compiler, a JIT compiler for Java, GraalVM native image, allowing the ahead-of-time compilation of Java applications, and Truffle language implementation framework, and the GraalVM SDK to implement additional programming language runtimes. Okay, the GraalVM compiler is a modern Java just-in-time compiler. It replaces the existing compilers such as C1 and C2 in a hotspot at client and server compilers. I will not dive deeper in this topic, but you could research it on your own. In contrast to these existing compilers, the GraalVM compiler is written in modular, maintainable, and extendable fashion in Java itself, and the GraalVM native image is a ahead-of-time compilation technology. It's a technology that produces executable binaries of class files. It's released as an early adopter plugin, which means it's production ready, but may include backporting capabilities and for updates in future releases. Okay, let's take a look on build steps we are passing through when we are using non-native solution. For instance, let's take a look on the Gradle build, and we are passing through the configuring, project, compile Java, process, resources, classes, assembling, testing, checking, building, and that's it. What we are going to do when we are using native compile? Native compile. First of all, configuring project, instrument, and task with the native image agents. It's kind of generating AOT tests and tests as well. And we are going through the compile AOT main Java, generation resource config file, and the native compile task completely brings us 7 steps. First of all, the initialization step, GraalVM, architecture type, and garbage collector type. Performing analysis, it's a kind of classes, fields, and methods to be reachable, and use it for reflections, and use it for GNI access, and building the universe, parsing methods, inlining methods, compiling methods, and creating image is the final step. Okay, and what we are going as an output. For non-native solution, we have kind of resources that had been processed before, and jar file as the final output. And on native solution, we have different structure, and it contains of context bootstrap initializers, static spring factories, factories loaders. All of them contains the long readable bin definitions that have been prepared before, and as an output we can find in a folder native compile Spring Boot Web Native the executable. You could easily run it from your command line tool, or for instance item tool, something like that. I created a business idea just for performance purposes and performance testing purposes, and I'll provide you some information about the application logic, use cases, and its database structure. So application logic. The application logic is transportation service. Typical transportation service, it works from 8 a.m. till midnight, and it works for about a bit more than 100 hours of load per week and 60 per day, and presets. Which presets I have? I disabled all application level caches to get clear performance metrics of the server as it is. The database and application are running in the same network to avoid net lags and penalties. The fetching strategy is eager, just to have non-optimized queries and to have a high load to the database, and second, to spend time to set up anti-graph and different presets. So the average time to boot up the service will not depend on the database structure. I'm not using migration tools such as Flyway and Liquibase. I've prepared it already and filled with fake data. How I did it, you could easily find in my GitHub. I have a description how I preset it, and you please follow the links in the end of the presentation. You can take a look on it. So as a loading testing tool, I choose Kotlin. Why did I choose it? Because if I had no any experience with Kotlin, and I'd like to gain this skill. And the presets of Kotlin also you can find on my GitHub profile, and feel free to visit it. The version of languages, frameworks, libraries, and databases are the latest long-term at the moment of testing. And now let's imagine the number of units in use. Units, I mean the entities we are using. I decided to launch the application for one country with 6 cities. Yep, I love my country. I'm from Belarus, and so in every city we have 20 points to be able to arrive and depart. And I assume that every point has about 100 transfer. The target audience is 200,000 users, and every one of them has at least 2 transfers. Use cases. I prepared use cases, and I used them in the Kotlin use cases creation steps. And as a user, I'd like to choose a country, city, origin, and destination, and the date of transfer. And I'd like to see all available transfers with this preset. And I'd like to book a transfer. I'd like to see all my transfers, to view any own transfer, edit them, cancel them, or complete that had been in past. And I'd like to see my profile and update it as well. And I've repeated it for about 20 minutes. It's a stress testing, not a load testing. So let's move on. What about the database? We have one country, 6 cities, 120 locations, 12,000 of transfers, 200,000 of users, and 500,000 users transfers. And the entity relationship diagram you could find here. The database size is for about 150 megabytes and dump size a bit less. Docker image with a prepared data set with the 160 megabytes. How I prepared it also you could find in my GitHub profile in the previous research. So let's move on. Let's move to the Spring Web. We'll take a look on basic configuration, test results, and Docker image analysis. And the basic configurations. Here you can find my machine settings. I complete all the tests on my local machine, and it's a MacBook with the Intel Core i7 and total number of cores 4 and RAM 32. As a GTK, I used as GTK 17, JCJ1, Gradle 751, and Spring Boot 272. And I provided here brief configurations I've used. Most of them are default, and let's take a look on the performance results. This performance can be completed on the undertow. We can take a look on the total requests. It's a bit more than 400,000 of requests, and 33% of them are with KO. Due to the fact that it was a stress test, we had a lot of timeout exceptions and kind of like this. So I could provide you a comparison with the Tomcat Jetty and Undertow in Docker. Undertow Docker I've built with a Jeep and using at the main image Dockerless. And in these cases, the boot up time for about between the 3 and 5 seconds for all solutions, and our saturation point was for about 1,600. And GVM consumption on the Tomcat 365 megabytes, and Undertow 650 megabytes, and kind of like this. But moreover, I would like to tell you about the Docker image that I've built, as I mentioned before, using the JIB and Dockerless. We can find the dive tool, if you know about the dive tool, provides us the image efficiency score is 100%, and the total image size is 280 megabytes. Okay, what about the Spring Web as native? I'll tell you about the basic configurations and pitfalls, test results, and Docker image analysis. And basic configurations are pretty same, totally same. And as the versions of the GTK, JC, Gradle, Spring Boot, but I've added Spring AOT. You can find that the major version is 0. So native is a kind of experimental feature and technique. Before all the comparisons, I would like to tell you not to bring it into production because of there are different kind of pitfalls you could face. And please be patient and wait when it will be stable. Okay, what about the pitfalls? When we are using APIs like REST template or web client, reflection-based reserialization like JSON requires additional type hits, Kotlin coroutines are supported, but currently require additional reflection entries due to how coroutines generate bytecode with an object return type. Sealed classes are not supported yet. Custom repository should be annotated with the component annotation. Doesn't support Hibernate types, and we had a discussion with Vlad Mihalte. But I had a workaround with this solution. Doesn't support Undertow or Jetty. You can use Tomcat only, but there are a lot of buts. But we could find different presets and special configurations for every starter we are using, for instance, for Tomcat or metrics we are going to use, or testing tools, and kind of like this. Test results pretty similar, but we can take a look on the our 97 percentile, and the response time a bit pretty. And we have for about 29% of chaos and a total request in 50,000 more. Now I would like to compare two different approaches to use a native Spring native solution. First of them is about creating lightweight containers using the build pack, and just take a look on this build time. I'll remind you that for non-native solution, we had a build time 5 seconds. For build pack, 700 seconds. To be clear, I drank for about 2 or 3 cups of coffee, just taking a look what is going on with it. In spite of this, we can find the boot up time. It's about 300 milliseconds. 300 milliseconds in Spring world. Unbelievable. Just really great boot up. And you have 4 services. Okay. And the other approach to use a native approach, using the native build tools, and this build time is for about 200 seconds, and boot up pretty similar, but RAM consumption is for about 260 megabytes, and CPU is pretty less. So what about the Docker image that we've created using build tools? Dive said us that we have potential base space for about 400 bytes and image efficiency score 99%. And total image size 145 megabytes. Let's compare them. What we could compare? We could compare different approaches for non-native solution and native solution. Using the Undertow, we can find that we have the build time 5 seconds. For native build tools, 200 seconds. And artifact sizes pretty different. Undertow 50 megabytes and the native tool 160 megabytes. Boot up, yeah. As I've mentioned before, the native approach provides a better boot up, and you can find that it's clear for us that 30 milliseconds is pretty better than 3.5 seconds. And what about the saturation point? Saturation point is pretty better. RAM consumption pretty less. Let's compare 600 megabytes and 260 megabytes. And CPU consumption a little bit less. And what's going on with this world? If you want to have faster boot up time, in 12 times, or you want to have less resource consumption in 2 times RAM and CPU, you could use a native solution. If you want a faster build time, it's 42 times, and a smaller artifact size in 2 or 3 times, and stable solution, use non-native solution. Take it. What to choose, it's up to you. I believe that every one of you knows your customer, and in some cases even better than the customer knows himself. And if you want to increase your time to market, you probably would like to take a look on the non-native solution that have a pretty faster build time. Your CI and CD will be faster. But if you want to launch and start up your applications in 12 times faster, you could take a look on native, but this is not ready for production. It has different kinds of pitfalls I've provided for you. And I would like not to bring it into production. Please do not do it right now at the moment. So I believe that that's it, kind of quick and brief presentation, and you could find with using this QR code my sources and a more detailed information with much more numbers and metrics and graphs. You can find different types of presets, such as a database configuration, Kotlin configuration on this GitHub profile, and you can follow me on the LinkedIn, on GitHub, or Instagram. I'll share on these social networks my next technical solutions and researches, and I'd like to ask you to provide your feedback, and it could help me to bring you more clear vision in the next talks. Thank you.
Thank you, Vadim. And if anybody have any questions, feel free to add this question to comments under the video. And see you next time. Next time we will make a stream in 1 week. Have a good day.
Have a good day. Thank you, everyone. Bye.